Welcome and hello. My name is Jacob Lozano. I currently work for INEO Waukesha Gas Engines, formerly known as GE Power Waukesha Gas Engines, recently acquired by Advent Financial, and now a standalone business known as INEO. Today I will be presenting on our VHP product, which is shown here on the left side. I will be presenting a business proposal on cylinder deactivation as a CMNU kit, also conversions, modifications, and upgrade. On the right side shows just some of the powertrain. You can see the pistons, the liners, valves, valve springs, and the cams, all required for cylinder deactivation to be controlled by our control system. Again, my name is Jacob, working for INEO. My specific role here is mechanical design and development engineer. I think we all know what design is, but development starts, just as a brief summary, gets into even finite element analysis, also known as FEA, including empirical testing, instrumentation such as accelerometers, pressure transducers, and thermocouples, to do model correlation then with the design and FEA models that we generate. Now, jumping into gas compression, what is it? Gas compression is not gasoline. We're talking about natural gas. Natural gas relies in low pressure wells deep under the earth, just like shale oil. But here, these low pressure wells that contain this natural gas needs to get distributed, of course, around the world. And getting it here, specifically in the US, you can see on the right side a graph or a picture showing in blue and red lines the different U.S. natural gas pipelines and how we go. You can see in Texas and in the Midwest that there's a very high concentration of these pipelines, and so there's literally millions of miles of pipelines in the U.S. alone that we have to pump natural gas, which comes with, of course, its own issues or own problems. Trying to get this natural gas to homes, businesses, and the city infrastructure so that they can operate as needed. Again, that problem is over these long distances. The pipes have different diameters, they're at different elevations, there's different twists and turns, there's different temperatures, different climates all around. So what happens is the density of the gas and the flow rate of the gas all gets affected because of these different parameters. What happens is this gas is now being slowed down, and being slowed down means losing pressure. So what we need to do is continue to pressurize the system continually. So you're spanning these gas compression sites hundreds of miles between each other in order for this natural gas to continue to flow to get to our customers. This is an inherent problem, but it's a problem that we're trying to mitigate and minimize. And one way to do that is actually a different approach of doing cylinder deactivation. Instead of approaching it from the how do we design the pipeline systems, it's how do we make our engine operable in different loads and in different speeds so that our engine can efficiently pump natural gas with reliability. So at the bottom I showed that a delta in the pipeline pressure then results in a delta in our engine load or work and our speed. When you get out of our operating range, you end up producing inefficiencies, which ultimately results in profit loss, profit loss, profit loss for our customers. They pump millions of BTU of gas every single day, and what we're trying to do is maximize that so that they can maximize their profits. Increasing the reliability of the engine now benefits us all. Here at Waukesha, we have one major competitor, which also comes with many downsides for that competitor, known as Caterpillar. Because they have the largest market share in the US, they're able to ask for more money for the same exact product. So here in Waukesha, we're able to have a better cost, and this is good for our customers. If they're willing to deviate from Caterpillar, or they're having issues or not getting the services that they need, they can consider Waukesha and get better cost, up to 20% a better cost than Caterpillar. We definitely have 50%, up to 50% faster delivery. So Caterpillar has a backlog. That backlog means that customers have to wait longer and longer for their engines. Sometimes this is okay, sometimes it's not acceptable. Here in Waukesha, we're able to deliver fast. We have 99.9 product reliability on our VHP product line. This is superior to the Caterpillar product. The Caterpillar is kind of known as the Ferrari, while the Waukesha gas engine is known as the Toyota. We run, and we're not so susceptible to minor tweaks causing our engine to go down. We have operational versatility, which again this CM&U kit will expand, and including emissions, we have some of the lowest NOx and COX emissions, even below what the EPA monitors, giving the customer more emissions credits for them to run the engine in other applications when needed without being penalized. Going into the technology now. Cylinder deactivation is simply what we see in the automotive industry. Whenever you're cruising down the highway, you can actually turn off half of the cylinders. You can run very efficiently. You're still going the same speed, but you're saving fuel, and you're even reducing the amount of wear on your components, which means that components will last longer, ultimately increasing the reliability of your asset that you have. So less gas equals more money in their pocket. Higher reliability means more money in the customer's pocket, less top-end overhauls, less bottom-end overhauls. And then emissions, not only is it good for the environment, but also it's again good for the customers themselves to run in a place to get credits, and for them to use those credits when times of being penalized, for them to remain again profitable. Now, getting a little bit more to the specifics of cylinder deactivation. Cylinder deactivation is not really a hardware component package. It mainly is a control system package. There's a few hardware, such as the hydraulic lash adjusters shown on the top right, that would be required. But these are minor. We don't need a new block or a new crank or new pistons or new heads. So cylinder deactivation, using the control system, we're able to monitor engine speed, engine torque, and that we're able to know the gear ratios that are using to couple to the compressors. We're also able to monitor plant-wide what's going on, pressures and temperatures within the piping. What we can do is build analytics. We already have analytics that are built to monitor the plant parameters, and what we can do is then proactively predict when cylinder deactivation will be able to be used. And once this goes on, we have the hydraulic lash adjusters engaged, closing the valves. We then optimize the combustion within the two-stroke cycle by monitoring our spark and fuel injection, turning those off, but then increasing those, which is in the third bullet point, of increasing the amount of fuel and air going into the other cylinders. So you're not cutting the amount of fuel in half, but what you're doing is you're increasing the amount of fuel just a little bit in those cylinders, still saving you money on the customer, and you then optimize that to get your efficiency up by optimizing your ignition timing. One of the key elements to this, to getting this product launched, is field testing. Field testing is the way that the whole gas compression market makes a statement to the world, and specifically here in the US against Caterpillar. So what we'll do is partner with two customers in 2020, of Q3 of 2020. It'll be Howard Energy, located in Texas, and it'll be Consumer Energy, located in the Midwest. If you remember that picture I showed on the very first slide of the distribution of pipelines, these are very concentrated areas that give us the most visibility in the market, so that our customers and even our competitors can then see the amount of savings that the customers are getting, and it gives us real numbers that aren't predicted, but now numbers that have actually been saved, and to prove the product itself. The gas compression market is a cyclical market. We know this. It goes about 5 to 7 year long cycles, and you can see that the cycle really began actually earlier than we expected, but it began in 2016. And so you can see in 2016 we had a large market share of roughly 30%. So during the cycle from 2016 to 2020, you can see that our market share happens to dip a little bit, and this goes back to management changes that we had internally, and a focus of, instead of this mid-range, we focused more on the lower range power. It was a bad prediction on our side, but with readjusting here in 2018 to 2019, we already have orders in, and we're already predicting in 2019, 2020, and 21 to gain a substantial market share. On the left-hand side of this graph is the amount of horsepower demanded by the US market. So the market is actually demanding in 2016 roughly 30,000 horsepower, and we supplied roughly 30% of that 30,000 horsepower. And so this shows that with releasing cylinder deactivation, it is towards the end, but what it allows us to do is come into the market, disrupt the market, allows us to gain even more market share in customers. And as the cycle begins to drop down in 2022, cylinder deactivation allows the customers to come back to us because they're able to buy engines that can run in the high or in the medium power range, but also operate in the low power range. So this then allows them to pretty much kill two birds with one stone by buying one engine. Now going into investing, there's a little bit of numbers here. On the right, I'm going to mainly focus on the 5-year financials at a glance, starting from 2021 when the product will be released. We're seeking a $1 million investment, and you can see in 2022 that we plan to break even. This already includes marketing cost of well over $500,000, the engineering costs that are well over $500,000, and the rest of the development necessary for this product and continual development in the following years. Now, what is it for the customer? Let's put this in perspective. So what we really have here is cost savings of, sorry, this is the wrong number, but fuel savings of about $25,000 per year. This $25,000 per year over the lifetime of an engine actually results in roughly $700,000 for the customer. And so the way we get this number is you have a certain number of hours per year. Most gas compression plants operate most of that time. And once you factor in the amount of the percentage that the cylinder deactivation is actually on and the amount of fuel that you save per hour times the number of the dollars of gas per hour, you get this number. This is a huge savings, allowing customers roughly every let's say 7 to 10 years to actually buy new engines if they need to add to their fleet. This is huge because you pretty much buy a kit in the front end, and every so many years you're actually able to add to your fleet as needed to expand your gas compression plant. Now here with the launch plan. In 2020, we plan to make a market announcement at the Gas Machinery Conference. This is a conference where all of the customers, different packagers, distributors, and others in the industry all come to find out what NEO Waukesha gas engines will be producing, what Caterpillar we're producing, and so forth. So this will be a major time for us to do our announcement, followed by in Q3 some field testing and some announcements continually in the gas compression magazine as shown here. Now what we'll do is then we'll get the packagers and the distributors up to speed, start making deals with from our packagers and distributors to our current customers and new customers, and then continue the continuous improvement for our product to stay on the leading edge of technology, providing our customers with the best amount of gas that they can pump per year. And that is it, folks. I appreciate your time.